This lesson pulls together several elements from the previous lessons to create an applet that displays leaves falling down to the bottom of the window and blowing away. Over the top of this picture, the current date and time is constantly updated. It may not be the most advanced applet in the world, but it can tell time. These constant values are defined to indicate the window will have 100 leaves falling down and that there are 4 images for the leaves. The picture of each leaf is in a GIF file and there are 4 of them. Each of the falling leaves will select one of the images. This is the string reference that will be used to hold the date string to be displayed, and these are the XY locations for it in the window. Notice that the string object is initialized to a blank string. There's a very good reason for doing that. I'll tell you about it when I get to the paint method. This is the array of image objects that's going to hold the leaf images for us, and these are the X and Y positions of each leaf as it falls. You may have noticed that we're not using double values for the locations this time. That's because it isn't necessary to have smooth motion. As each leaf comes down and blows away, we actually jiggle it a little. Here we select a nice font for displaying the time and date, and right here we set a bottom value. This value is compared against the Y position of a falling leaf, so we can determine when it reaches the bottom of the window. The leaf images are 20 pixels tall, so if a leaf is inside 18 pixels from the bottom of the window, we quit making it fall. We load the leaf images from the server and store them in this array. We add each one to the media tracker and we wait for all of them to load. Finally, each leaf is positioned horizontally off to the right, so the update method will assume it has blown away and will drop it from the sky again. This for loop in the update method moves each leaf in the array to its next position. A leaf can be treated in one of 3 ways. If the leaf has been completely blown out of the window and is off stage right, we set both its X and Y values so it'll drop from the sky again. Vertically, it's placed out of sight at a random distance above the window. Horizontally, it's placed randomly between the 2 sides. Actually, it may be placed a bit to the left of the window because the leaves blow over to the right, and if none ever went all the way over to the left, the lower left end of the window wouldn't have a leaf. You'll see what I mean when you see the applet run. Now this else-if combination in the syntax can be used if you have more than 2 options to choose from. This isn't any kind of special structure or anything. It's just a consequence of the natural syntax of Java. I kind of like this else-if form, so I tend to use it a lot. Here, if the leaf has fallen to the bottom of the window, the horizontal position is adjusted somewhere between 0 and 2 pixels to the right. Using a different value each time adds to the jerky movements, and that adds to the charm of the applet. The vertical position is moved up or down 1 pixel, or it is left where it is. This is also for the purpose of adding jiggle. If neither of the 2 previous cases were true, then this must be one of our falling leaves. The horizontal position is changed to the right by as much as 2 pixels, or it may be left where it is. The vertical position is increased by 1 pixel, causing the leaves to all fall at an even speed, but they wiggle a bit while they do it. This is an example of using a Java class without naming it on an import statement. By using its full name every time it's referred to, we don't leave anything undefined for the compiler to search for. Anyway, we create a date object without an argument, so it contains the current date and time. The date class of Java has lots of methods for doing arithmetic and comparison of dates and times. It keeps time to the nearest millisecond and has a range of several thousand years in both directions from where we are right now. We don't have to worry about another Y2K problem for quite a while, probably until the year 10,000, when they find that COBOL needs another digit. Just like any other object, the date object can be converted to a string by calling the toString method. This string is the one that we want to display. Using a font metrics object, we calculate the X and Y positions required to center the string in the window. In the paint method, this loop paints each of the images in its current XY position. This line of code is used to select the image to be used for each leaf. There are a lot more leaves than there are images, so the index into the array of X and Y leaf location is divided by the number of images, and the remainder is used as the index into the array of images. This is the modulo operator that we talked about earlier, and it seems to come in handy in the darndest places. Here the color and the font are set for the string, and the string is drawn on top of everything else in the window. It could have been drawn earlier and the leaves would fall in front of it, or you could even draw some of the leaves before it and some after it, and some of the leaves would go behind and some in front. Anyway, I mentioned at the beginning that it was necessary to initialize the banner string. The reason for that is the web browser may call the paint method before you're ready for it. If, when you spawn a thread to do the animation, the web browser decides to make a direct call to paint first, a null string here would give you a problem. This happens a lot with threads being asynchronous. Just remember this: the paint method should always be ready because it can be called at any time after init, even before start. Never trust a web browser. Program defensively. When you run this applet on your system, you'll notice that the time is the local time for your computer. I can see by the time here I've missed lunch, so I've got to go.